All right, hello everyone. My name is Fizza Afreen, and I'm a current space architecture graduate student at the University of Houston. And just like my peers, this past summer, I had the opportunity to complete the Young Scientist program through Blue Marble Space Institute of Science, where under the guidance of Dr. Jennifer Blank, I worked on a project to conceptualize futuristic human habitats or settlements for 100 humans on either the moon or Mars, and to use various generative AI tools to bring these habitat concepts to life. So my project is called The Future of Mars Surface Habitation. I chose Mars primarily because I wanted to imagine what human life would look like on another world that shares a similar day-night cycle as the Earth. A solar day on Mars is approximately 24 hours and 40 minutes long. And I focused on surface habitats because I imagined the first humans on Mars to live and work on the surface. So this project was also inspired by a study called the First Mars Outpost, which was conducted by the Sasakawa International Center for Space Architecture during the 2001 to 2002 academic year. This study proposed design concepts for reaching Mars and establishing a human presence there. Two proposed concepts for surface habitation were the Mars surface habitats, shown on the top right over here, and the Mars surface laboratories, shown on the bottom left here. The Mars Habs are designed to support 8-person crews for missions lasting up to 500 days. And the Mars Labs are science laboratory modules that are made out of inflatable structures and telescoping structures. An inflatable structure is basically a structure that is made out of flexible or lightweight materials that expands upon pressurization like a balloon to provide an enclosed livable volume space. So for this project, I designed a Martian habitat called the Adaptable Inflatable Mars Surface Habitat. And the goal of the Ames habitat design is to be adaptable to various mission needs to enable long-term human exploration of the Martian surface. So the three primary features of this habitat are its inflatable structure, which is where the astronauts will live and work. And then there's a rigid central module. This is where command, control, and communication activities will take place. And then the third part of this habitat is a dome-shaped structure that is see-through. And this is where sunlight can pass through, and this area can be used for growing plants and provide a more natural environment. So these three were the main features that I wanted to be able to generate using various AI tools. So when I first started, my initial goal was to be able to generate the basic structure of this habitat. So the following are my initial attempts. I started off with simple prompts as I was interested in seeing the general structure. And so for every prompt, I asked for the inflatable structure, this rigid central structure, and then the dome-shaped structure. So here is a resulting image from this prompt. And now I would just like to make some general observations for this. So over here, the AI was able to correctly place the inflatable structure over the dome-shaped structure. However, the inflatables over here were disc-shaped or donut-shaped structure. It produced like a layered inflatable that is separated by rigid circular platforms here. And it also generated like an entry and exit port to enter the dome-shaped structure and included small stairs and ramps. However, it doesn't have a distinct central module that connects the inflatable to the dome. So that was an element that was sort of missing over here. Now here is another prompt, and over here I added a little more, some more details to the prompt. So over here I specified that the inflatable structure should be vertical. And I added more interior details for what I wanted to see inside the inflatable, like a central core and 3 floors where the astronauts can live and work. Over here, I also provided an estimate for for the height of the central module. So I mentioned that it should be 1/3 the height of the inflatable structure. And then over here, I also mentioned that the dome-shaped structure should show plants growing inside it. So here is the resulting image from that prompt. And some of the strengths of this image are that the inflatable structure is the longest part of the habitat. So using the term vertical here was useful. And a central core is visible inside the inflatable. And there are multiple distinct floors also visible here. Now, in this image, the rigid central module is essentially this small structure here. And it is approximately 1/3 or a little less of the height of the inflatable. But the rigid central module is not like as wide as the diameter of the inflatable. So instead, the AI just produces a small rigid central module here and produces these additional support structures to connect that to the dome. However, on its own, the AI also produces this structure within the dome that connects everything together. And so that was something it did on its own. And another thing that worked well over here is that plants were shown growing inside the dome-shaped structure. However, for this prompt, since I did not mention that there should be entry and exit ports on the dome, it did not include those. So that is a weakness of this image here. Now, for the next part of my project, I was interested in visualizing more of like the habitat interiors, and so I started to write more detailed prompts to be able to make that possible. And so here is a sample prompt, and this prompt is structured as follows. The yellow text refers to the inflatable structure and its interiors. The blue text refers to the central module and its interiors. The green text refers to the dome-shaped structure. And then the orange text is just information about what I would like to see outside the habitat, like rovers and equipment for in situ resource utilization activities. So here is a resulting image from this prompt. And I really like the complexity of the details over here. So what went really well here is that 3 floors were visible inside the inflatable, but the second floor takes the most amount of space inside the inflatable. And then it also includes a tubular structure with windows. And this is where I would imagine the crew quarters to be. Some other strengths of this image are that the relative size of the habitat to the astronauts is quite ideal here, as this is clearly a large habitat that can support multiple people on Mars. And then there are distinct paths for astronauts to walk on inside the dome over here, which is a detail that I included in this prompt, so it was able to do that. And the dome here represents a really nice garden space. So that natural environment is definitely very visible over here. And then the AI also produces multiple entry and exit ports in the dome here. So these were the main strengths of this image. Some of the weaknesses were that the inflatable structure here looks more like a rigid metallic structure rather than an actual inflatable. And then again, there is no rigid central module that connects the inflatable to the dome. So that element is still missing over here. So there are only the 2 features of my habitat, essentially the 2 big features were visible here, the inflatable and then the dome-shaped structure. So now, as I mentioned, this tubular structure is where I would imagine the crew quarters. I actually wanted to visualize that further. So I decided to write a prompt that says to create an image of a spiral tubular structure inside a large room inside a Mars surface habitat. This spiral tubular structure should contain windows and must serve as the crew quarters for astronauts. Show beds, tables, and chairs inside the structure and show the astronauts residing within it. So this was the resulting image from this prompt. And what I really admire about this image is that it's quite realistic. And a tubular structure like this could be an efficient way of using volume space to house a large number of people. Or it could also serve as resting pods for astronauts where they can go in between their work shifts. So these pods could be spaces where they do some personal study or take a break from work. And the windows of this structure could be designed to change transparency so that they can be made opaque when needed to provide additional privacy. And so this is just one way how something that the AI generated on its own, I wanted to like explore that feature further. And so now just to remind everyone what my habitat looks like, now I also wanted to visualize some other details of this habitat. So I also wanted to write prompts to be able to further visualize the telescoping central core here, which will be the structure inside the inflatable. And then these airlocks over here are also elements that I wanted to visualize further. So the next couple of images will look into, we'll go over AI images where I'm trying to visualize these features. So in this prompt, I basically ask the AI to create a large cylindrical room inside a Mars surface habitat. At the center of the room, place 3 rigid see-through cylinders stacked on top of each other. These cylinders should take up more than a third of the floor space and be taller than the humans around them. The 3 cylinders should be connected inside and contain a central elevator. The 3 cylinders should be equal in height but have different diameters. On the side walls of the room, show humans standing, tables, chairs, and a variety of equipment. So the main elements of this prompt were that the room should be cylindrical and that there should be this cylindrical core at the center of the room and that there should be an elevator inside. So these were 3 important details that the AI was able to replicate, as well as some other details, but it was not able to get some of these like dimensions correct. So here is the resulting image where this is a large cylindrical room that is 3 floors, and this is the central core with an elevator inside. However, as I mentioned, some details that it was not able to get is that the cylinders here are all the same, like they have the same diameters. However, in my habitat, I created the telescoping core where the cylinders are of different diameters. So you start off with like a big cylinder and then you have smaller ones on top of each other, on top of them. But it wasn't able to produce that. However, if this were an inflatable structure, then these would be like the 3 floors of the inflatable before the floors are actually attached over here. And this is what the central core would essentially look like. Now for another prompt here, so here I'm trying to look into one of the cylinders and trying to create like a storm shelter using that central core. So here I asked the AI to create a large cylindrical room inside a Mars surface habitat. Place a rigid cylinder at the center of the room that reaches the ceiling. The central cylinder should include a water bladder in its walls. The central cylinder will serve as a shelter from space radiation. Show water running through the walls of the central cylinder, and then place humans inside the cylinder and show them seated on chairs with cushions. Do not make it seem as if they're inside the water. On the exterior of the central cylinder, place a door that can be used to enter the cylinder. Show an elevator inside the central cylinder. So these were the main details that I wanted to see in the image. And here is the resulting image where this entire like space would essentially be one of the floors of the inflatable habitat, and one cylinder of that central core would be turned into a storm shelter where water is running through the see-through walls of the cylinder, and it is a space where astronauts can go to during like solar flare events and solar storms. So this will provide a space, a protected space for that. So some of the details that I highlighted in my prompt, it was able to show that there was a central elevator or a structure that could be a central elevator was shown here, as well as a distinct door to enter the structure here. And then the astronauts were seated on chairs. Now this prompt is to visualize the airlock. So over here, I asked the AI to create a realistic image of an airlock for a Mars surface habitat. The floor plan of the airlock should be a circle. Now in my habitat, the floor plan was a semicircle, but unfortunately the AI was not really able to produce that. So I decided to just stick with a circle. And then I asked the AI to place seats for astronauts near the curved walls and show the astronauts seated. close to the seats, show spacesuits hanging in airlock systems. At the center of the airlock's floor, place an elevator system that will be used to exit the airlock. This elevator will take the astronauts to a module below and show an astronaut inside the elevator. So here is the resulting image from that prompt, and the small details that I highlighted were all represented in this image. So the floor plan is circular here. The astronauts are seated near the walls of the airlock, and there is a central elevator with an astronaut within it. So this elevator is how the astronauts would move from this airlock and go down to a module below this airlock, or just go down to the Martian surface. And now for the last part of my project, I wanted to visualize large human bases on Mars built using the Ames habitats that can support up to 100 humans on Mars. So over here, I went back to writing simple prompts, but I still asked for the three main features of my habitat concept, which are its inflatable structure, the central module, and a dome-shaped structure. However, in this prompt, I do specify that this should be like a large human base, and there should be multiple like rovers, astronauts, and equipment seen outside the habitat. So here is a resulting image from that prompt. And this is clearly a large base due to the amount of rovers, astronauts, and equipment that are visible on the surface. And over here, again, the AI, it produces like a layered inflatable structure. And these inflatables are like donut-shaped, separated by rigid circular platforms. So I would assume like each layer to represent one floor in this inflatable structure. And then the dome is quite wide over here, connected to the inflatable. However, there is still no distinct central core that connects the inflatable to the dome. That element is still missing over here. But nonetheless, it was able to show plants growing inside the dome and multiple astronauts scattered across these habitats. So this is clearly a large human base. And now here is an image that was a refinement to an image produced using the previous prompt. And so over here, I basically asked the AI to connect the surface habitats with tunnels so that the astronauts can move between these habitats without having to wear their spacesuits. And so again, this is essentially the inflatable structure of these habitats, and then there's a large dome over here. However, something I really liked about this image are that the entry and exit ports over here seem more robust than the ones in this image, for example. So these entry and exit ports could perhaps be designed in a manner where they can contain atmosphere within this dome, or like designed such so that the atmosphere loss is very minimal. So these are pretty robust entry and exit ports, and other than that, the AI still shows a lot of rovers, astronauts, and equipment on the surface. So this does represent a pretty large human base on Mars. And now here is another image. This was produced using ChatGPT, and this is one of my favorite images from this project because the three main features of my habitat concept were clearly represented in this image. So there is an inflatable structure, a central module, and a dome at the bottom of those two. So those three features were clearly seen over here. And this is just an image where I wanted to see multiple of Ames habitats on this scattered across the Martian surface. And here is an animated version of this image. So this was also produced using an AI tool. And over here, I basically just asked the AI to show the astronauts moving on the surface. Now, to conclude my project, I would like to talk about the benefits of using generative AI. So firstly, generative AI can help us quickly convey design ideas, which would be useful during the early stages of a project, as it can help us think about the feasibility of a design and make changes early on. And secondly, using AI tools can help us improve our innovative thinking and critiquing skills. These tools can help us imagine what could be possible in the future and what we need to do today to get there. Lastly, content produced using generative AI is useful for public education and outreach to inspire the next generation of scientists, futurists, and creative thinkers. And that is the end of my presentation. I would like to thank Dr. Jennifer Blank and Blue Marble Space for this opportunity, and I'm open to any questions. Thank you, everyone.